All right, today is transformations. Now, Miss Wheeldryer hammered on this in Algebra 2. Okay, so you should be good at this. Okay, you should be good at this. Transformations, we're doing vertical and horizontal, reflect across an axis. So we'll have to know, when do we reflect across the x-axis? What makes it reflect across the y-axis? What moves it right? What moves it left? What moves it up? What moves it down? And combining transformations. So you can understand relationships between similar graphs. Okay? So rigid transformations leave the size and shape the same. Non-rigid distort the graph. So when we're multiplying by a number to stretch and shrink, that's non-rigid. When we're just adding numbers or subtracting numbers to move them, that's rigid transformations. Okay? So, horizontal transformations. This is important. When it happens inside the parentheses, it's a horizontal transformation. Inside the parentheses is a horizontal transformation. And it's opposite with what you think. If you're subtracting, you're moving to the right. You think minus, you move to the left. No, minus, you move to the right. Addition, you're moving to the left. Vertical transformations happen outside the parentheses. So plus moves it up, minus moves it down. So what happens outside the parentheses is what you'd think. What happens inside the parentheses is opposite of what you'd think. Okay? Because normally you see a plus, you go to the right. You see a minus, you go to the left. Well, it's opposite when you're inside the parentheses. Okay? So, inside the parentheses, left and right. Outside the parentheses, up and down. So let's look at the graph of f of x equals the absolute value of x. What does the absolute value look like?
V.
A v. Is our transformation happening inside or outside the parentheses? Outside. Outside. So if it's a minus 4, you're going to slide which way? How far? Down 4. 1, 2, 3, 4. Looks like that. Okay? All right. So this red one is y equals x cubed. Okay? What is the blue one here? What would the blue one be?
Y equals x cubed minus 3.
Y equals x cubed minus 3. Because we moved it down, it happens outside the parentheses, it would just be minus 3. To go from here to this one, what would this blue one be?
Plus 2, but in the parentheses.
Plus 2 in the parentheses. So y equals x plus 2 inside the parentheses cubed. Okay? So then what would this blue one be if we moved this way? Minus 3 in the parentheses. Y equals x minus 3 cubed. Okay? And the answer is on the bottom. All right. So if we're flipping across the x-axis, when you go across the x-axis, you go outside of the function with a negative. If it's across the y-axis, it's inside the function with the negative. And if you're doing both, it's both. Is anybody still hungry for lunch? No. Because that was my wife calling, and obviously I didn't answer because it was my wife calling. And she could just walk down here and talk to me if she needed to. But she said, Well, if anybody's hungry, I can bring some pizza down. But it's school pizza.
Yeah, I'm hungry.
Ice cream.
No ice cream, just pizza. John, you're always hungry. Grady's always hungry.
Okay.
No, I'm not calling you fat. I did not say that. That did not come out of my mouth. And now it's on the recording. Oh my goodness. So funny. I love you guys, by the way. You guys are great kids. All right. So these two graphs are very different. Okay. So, and absolute values outside the function is different than an absolute value inside the function. Okay. Stretches and shrinks. Okay. We stretch or shrink horizontally if it happens inside. We stretch or shrink outside, or if it happens outside, it goes vertical. And I would rather them write this way. F equals 1 over C times X. I'd rather see that, but X over C works too. Okay. And we'll get some practice at this. All right. So let's say we have this function. Okay. If we have a vertical stretch by a factor of 4, what would be the new function? Well, it would be just 4 times the original function. Okay, so if it's a vertical stretch, happens on the outside, and it's just the way it would be. I don't know. I don't know where they have the +3, but okay. A horizontal shrink by a factor of 1/3. So if it's 1/3, it happens on the inside of the parentheses. So basically, if we're shrinking it by a factor of 1/3, we're multiplying each thing on the inside by 3. And that would shrink it by 1/3. So let's look at y equals x squared. If we're making a horizontal shift 5 units to the left, it happens inside the parentheses. A vertical stretch by a factor of 3 happens on the outside of the parentheses. And translation 4 up happens outside the parentheses. So that's what it should be. All right. So What does this do to the graph originally? Moves it which way? Right by 2. Okay. Then we're going to do this to it. What's the negative on the outside do? Flips over the x-axis. So up 4, we're down 4, 3, that. And then the plus 4 moves it up 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I think I screwed this up. Yeah, this one should be here. So it's here. So it's here. Besides that, it should look like that. There we go. Okay, discard. Boom. 6A. Boom. Boom. Okay, what does this tell us to do? Right by 3 units. We do 2 things to this. First thing is right by 2, and then down by 5. Right 2, down by 5. This one tells us to do 2 different things. If it happens on the inside of parentheses and it's got a negative, it'll flip it over the y-axis and then translate it 1 down. 4 on the inside is the same as saying, okay, how is that? 4 in the inside is the same as saying y equals 1 over 1/4. Okay? It's like it's 1 over 1/4 to have a whole number of 4 in front. Okay? So it's a horizontal stretch of 1/4. So it's a, is it a shrink or a stretch? How do they describe it? That's a good one to know. So we will see for sure. Horizontal shrink by 1/4. So we shrink by a factor of 1/4. So if this is 0.4, 0.4 is the same as 4/10. Well, when we're dealing with this, we want a 1 on the top, so then that would be 10/4. So see, I don't like how they do that. So it should be, this should be a stretch of 2.5. So it would be a horizontal stretch of 1 over that. This is, I think, makes more sense than what that does. But whatever. Horizontal stretch on that one. Yeah. Why would it be a stretch? Because if you take 1 divided by 0.4, you get 2.5. So you're stretching it 2.5 times out. Okay? Because you're dividing by a number.
You always have to put it under 1.
Yeah. That's what I was taught when I was a young lad, is to make sure 1 is on top. So when you're doing this, we'll see if I'm right. Horizontal stretch, because it stretches it out 2.5 times. Okay? Describe how the transformation of the graph from here to get the graph of f into the graph of g. What's the difference between these two? the plus or minus in front and something else. This is a positive, this is a negative. So we really added 8 to this one on the inside, okay? Because it's x minus 4 plus 8 cubed, and then put a negative on the outside. The negative on the outside flips it over the x-axis, and then we add 8 on the inside, moves it where 8? Left 8. Left 8 across the x-axis. All right. So if we start with x squared, because that's what we should start with, that's the basics of this. What happened first? Multiplied it by, we started with x squared. What do we multiply by? 4 on the inside, which is really 1 over 1/4. So it's a shrink of 1/4. It's 1/4 as big. Okay? So we got to find vertically shrink and translate. Oh, it's choice A. So it's a horizontally shrunk by a factor of 1/4, and then we translate it down by 1 unit. Okay? So the 4 is really 1 over 1/4. I want 1 over something here. Okay? If this is a number bigger than 1, it's a stretch. If it's smaller than 1, it's a shrink. We start from the inside. Which way did we go? 4 to the right. Then we move to here. What does that do if it's on the outside? We flip over the x-axis and actually we stretch it by a factor of 5 because it's 1 over a number. This is, if it's the number down there is bigger than 1, it's a stretch.
Wait, so why don't they just write it like that though?
Because it'll do the wrong thing to the graph if they just write it like that. So that's where it gets confusing. Is this? It's this number that you look at, not this whole thing. Okay, so this is a stretch by a factor of 5. Then it'd be a shrink of 1/4. Yep. So it's 1 over, and then that's the stretch or shrink down there. Then what's our vertical shift? 2 units down. Okay. All right. I think. What happens on this one? What does it tell us that we're doing on this one?
Horizontal stretch.
Four x is 1 over 1/4. So it's a horizontal shrink. So we're going shrinking it down. So it's either this one or it's this one. Which one would it be? A, because there's no negative. If there was a negative, then it'd be D. Okay?
Would you times the 4 up and then it'd be 4 over 1?
Yeah, so 1/4 on the bottom is the same as 4 on the top.
Yeah, but then, so then 4 on the top, 4 times x would be a stretch, no? Or, yeah.
No, you are not getting this. It has to be 1 over, and that tells us what we're doing.
Yeah.
Okay? So 1 over 1/4, if this number is less than 1, it's a shrink. If this number is greater than 1, it's a stretch. But that's after we manipulate it to write it 1 over something. Okay? So if it's just a regular 4 here, it's going to be a shrink of 1/4. Because this isn't written as 1 over. So if you write it 1 over, then it should make sense. A number smaller. I am for John.
If you multiply 1 over the 1/4, if you multiply it by 4, then the top becomes 4, and the bottom becomes 1.
Right.
That makes more sense to me.
But
You just
anything
think of
times 4 gets bigger though.
Can't you just think of it as like if it's a whole number, like if it's greater than 1, it's a shrink.
Yep.
But if it's a fraction, it's a stretch. So it's like the opposite.
Yeah. So if it's inside the parentheses, it's opposite of what you would think. Okay. I don't care how you guys think of it, but we've now presented it in 2 different ways. So hopefully you get it. Okay. Yes.
You don't?
Can I get a different export marker? This one.
Yep. Yep. Throw that in the trash. Cabinet. Not behind the rock, but right, the one just to the left of the rock. No, not where the calculators were. Upper cabinets. Upper cabinets. Stop. See the rock? Just the left side of the rock. There you go. All right, your 12 problem assignment should be out there now.
What was this section called?
It's called 1.6a, but it's transforming graphs. Suppose I should stop the video.